In this video, I explain about the continuity equations. So it is a equation based on the principle of conversion of mass is called as the continuity equations. So in a thermodynamic, you also study the conversion of energy. That is the first law of thermodynamics. What is the statement for conversion of energy? Energy is neither created nor be destroyed. It is transferred from one form to another forms. So how we can correlate this conversion of mass with conversion of energy? So in a conversion of energy, energy remains constant. In a conversion of mass, the mass remains constant. Instance of mass, we can also say that the quantity of fluid per second is constant at the various sections of the pipe, or as well as inlet or at the outlet of the any pipe or any systems. So now we can consider the fluid is flowing through the pipe. At all the cross sections, the quantity of the fluid per second is constant. So here we consider the one pipe, and here we see the area of the pipe is gradually increasing towards the outlet. So this is the inlet, this is the outlet, and here we mention the two cross section. This is the one cross section, this is the second cross sections, and the fluid have certain properties at inlet as well as the certain properties at the outlet, but its value may be different. So let us we consider the V1. So V1 is the average velocity at the cross section 1 means the V1 is the velocity of the fluid at inlet. Rho1 is the density at the section 1 and A1 is the area of pipe at section 1. Similarly, at the section 2 V2, Rho2, A2 are the corresponding value at the section 2 means V2 is the average velocity at the section 2 means at the outlet. Rho2 is the density at section 2 or at outlet, and A2 is the area of pipe at section 2 or at the outlet. Now here we first need to make the equations for the quantity of the fluid per second at inlet and at the outlet. The rate of flow at section 1 means suppose the water is passing from this pipe. So how much water is passing from this pipe? So it is the density into area into velocity, or suppose we can say the what amount of the volume of the water is passed from here. So it is the area into velocity. Here we multiply it with density because for the incompressible flow, or sorry, for the compressible flow, the density is also changed. Okay, so for that case we need to add the Rho1 terms and the Rho2 terms respectively at the equation of the inlet as well as the outlets. Second, the rate of flow at section 2 it is the Rho2 into A2 into V2 means density into area into velocity at the outlet. So according to the law of conversion of mass, the mass is constant at the inlet as well as the outlet means these two values are same. Which two values are same? Rho1 into A1 into V1 is equal to Rho2 into A2 into V2 means the rate of flow at section 1 is equal to rate of flow at section 2 and we have this equation for that. So Rho1 into A1 into V1 is equal to Rho2 A2 into V2. So this is our equation number 2. So this equation is applicable to the compressible as well as the incompressible fluid. So we already studied what is compressible and incompressible fluid in a last videos. Okay, so it is applicable for both type of the fluids. So if the fluid is incompressible, means fluid is incompressible, that means the density is constant at inlet as well as the outlet. That means the Rho1 is equal to Rho2, and when this Rho1 and Rho2 is same, then we can cancel it out. Okay, then this continuity equation 2 is reduced to this equation, that is A1 into V1 is equal to A2 into V2. So which are the various incompressible fluids? Means various types of the liquid is incompressible, water is incompressible. So when you study the different type of the systems like as the venturi or a pipe, so majority in a fluid mechanics you can solve this numerical related to the liquids. So at that time you need to use this equation, that is A1 V1 is equal to A2 V2. But when you study that is a computational fluid dynamics, so in computational fluid dynamics that is a different types of the gases and air are taken for the examples. So at that time we need to use these equations that for the air or gas the density is also changed. Okay, so that regions we use these equations for a compressible fluids, and for incompressible fluids we need to use this equation. Means for the liquid we need to use these equations, for air or gas we need to use these equations. So thank you for watching this video. If you learn some things, then like the video and subscribe my channels for watching the more video related to fluid mechanics and other subject of mechanical engineering. For the fluid mechanics, various link is provided in descriptions as well as in car. For other subject, I request to visit the playlist and don't forget to share with your friends.